Lesson 2 of Chapter 5 is on the properties of quadratic functions in standard form. So we're going to be looking at all the specifics. We're going to take a look again at the vertex form that we did on Friday, and also look at what's called standard form for a quadratic function. And then we're going to look at all the different properties for it and identify them. So I think we mentioned the word the other day, talking about what's called the axis of symmetry. And the axis of symmetry, the axis of symmetry is actually a line that cuts a graph in half. So since all of our graphs open vertically, either they smile, open up, or frown and open down, then we have this vertical line that's called the axis of symmetry. When you draw it, we make it a dotted line. But what it does is it cuts the graph exactly in half. And it goes right through the vertex. So if we have our quadratic function in vertex form, remember, here's our vertex form here. If you have it in vertex form, then the axis of symmetry is just the line x equals h. So the axis of symmetry is a vertical line that cuts a graph in half. When it's in vertex form, it's the line x equals h, because it's whatever the x value is of the vertex. So the first thing we're going to do is just look at finding the axis of symmetry when it's in vertex form. So here in example 1, we want to identify the axis of symmetry for this graph. And so first of all, let's write down what is the vertex for this graph then, for this equation. Okay. What's the vertex? Okay. -5, -8 would be the vertex. Okay. It's h and k. So the vertex is -5, 8. So that means then that the axis of symmetry which it says right here is just the line x equals h. So h in this case is -5. So the axis of symmetry would be the line x equals -5. So if you can identify the vertex, then you can find the axis of symmetry. Now, most of the time, you're going to see quadratic functions written in standard form, ax squared plus bx plus c. And when we did this back in Algebra 1, that we did a lot of things with that. We did a lot of factoring with it and things like that. But you always saw it in this form, and that's called standard form. Okay? The a in standard form is the same as the a when it's in vertex form. So let me write the vertex form back up here again. So there's vertex form. So the a is the same as it is in vertex form. So if it's negative, it means it's a reflection over the x-axis. So vertical reflection. And it also tells us whether it's stretched out vertically or compressed vertically. The value of b is equal to -2ah, which is calculated from the vertex form. And the value of h then for our function then, for the vertex then, is found by doing b over -2a, or we're going to write it as be negative b over 2a. Right? So therefore the axis of symmetry, which was x equals h, that we can refer to it as then negative b over 2a. So we'll use x equals h if it's in vertex form, and we'll do the calculation negative b over 2a if it's in standard form. The value of c then, which is the y-intercept, is equivalent to ah squared plus k. Right? So if I let x equal 0, then it would simplify to ah squared plus k. So c is what we call the y-intercept, number by itself. Done a lot of work with that. So here we have these properties of a parabola. And these are something you're going to want to write down. These are things that you're going to want on your note card for sure. The parabola opens up. If a is positive, it opens down. If a is negative. The axis of symmetry is found by calculating x equals negative b over 2a. The vertex then, so once we know the axis of symmetry, that tells us the x value for the vertex. Then to find the y value for the vertex, we'll just take that x value and put it back in for x, and that'll give us the y value. So the vertex is found by negative b over 2a, and then once we get negative b over 2a, we'll take that number, put it in for x, and that'll tell us the y value for the vertex. And then the y-intercept is c. So what we're going to be doing is they're going to give us a function in standard form. We're going to tell which way it opens, what the axis of symmetry is, the vertex, the y-intercept, and then we're going to graph it. So we're going to do all 5 of those things for these functions. So it's one of those things that it's very important that you take your time when you're working on it. So when it's in standard form, one of the things that you should do is identify the values of a, b, and c. So that you know what they are, so that you can use them to find the parts of this function. All right, so what's the value of a in this case? Okay. B is negative 4, because it's ax squared plus bx plus c, and then c is 5. Okay. So letter A says determine whether the graph opens upward or downwards. So if A is positive, when you're feeling positive, you do what? You smile, so that means this is going to open up. Letter B, they want us to find the axis of symmetry. When it's in standard form, then, we're going to calculate negative b over 2a. And this part is very important because eventually when we're looking at zeros again, and finding zeros, we use negative b over 2a as part of the quadratic formula. So we'll be using it then. So we have the opposite of our negative. B is negative 4, and a is 2. So we have the opposite of negative 4 over 2 times 2. So x equals, well, what's the opposite of negative 4? Positive 4, and 2 times 2 is, so we get 4 over 4, which is 1. Okay. So there's our axis of symmetry, is x equals 1. Okay. And that tells us the value of h for the vertex. So now to find the value of k for the vertex, that means we need to find the y value. So we're going to take and we're going to put 1 in for x. So k is going to equal 2 times 1 squared minus 4 times 1 plus 5. All right, so the value of k for the vertex, we're looking for hk. So we get, what's 1 squared? 1. So 2 times 1 is 2, minus 4 plus 5, which equals 3. Okay. All right, so my vertex then is the point 1, 3. All right, so A tells us whether it opens up or down. To find the axis of symmetry, we do x equals negative b over 2a, and that tells us the value of h for the vertex, the x coordinate. And to find the y coordinate for the vertex, or the value of k, then we are going to put 1 back into our equation, what we get for the axis of symmetry, and find the value of k. All right, letter D then. They asked us to find the y-intercept, and the y-intercept is what? It's 5. The value of c is the y-intercept. So the y-intercept is 5. Okay? It's not a point. Nope. The y-intercept is the y value that where it crosses the x-axis. No, you don't have to put 0, 5. Okay? All right, and now we're going to graph it. And so we're going to use that information we just found to graph it. First thing we'll do is graph the vertex. Okay. The vertex is the point 1, 3. So we need 3 points to graph. Okay. Usually when we do these problems, okay, they're going to give us 2 points, and the third point is actually very easy. Right? So they give us the vertex, and what else do they give us the graph? Okay, the y-intercept. So if I graph the vertex and the y-intercept, that means that I know that the graph is going to go up to the left, right? Starting at 1, 3, and then going through the vertex, or going through the y-intercept at 5. Okay. Well, this is where the axis of symmetry comes into play, because the axis of symmetry tells us that it cuts the graph perfectly in half. And since it cuts it perfectly in half, any point on the left side of the axis of symmetry is also on the, okay, all right, if it's on the left side, it's on the right, on the left. So over here then, since we know this point at 0, 5, the y-intercept, in away from the axis of symmetry, it's 1 to the left of it, right? The axis of symmetry is the vertical line at 1. So that means then I have a point at 2, 5 also. Because that's my axis of symmetry is here. And any point, since I went 1 to the left of there to get to positive 5 for the y-intercept, then I go 1 to the right, the other side. And then I just draw my graph. So we use the axis of symmetry to help us to graph from one side of the graph to the other. So there's the 5 parts that we're going to do. So let's do another one. So we have negative x squared minus 2x plus 3. And once again, the first thing you're always going to want to do is identify A, B, and C. So Chris, what are A, B, and C? I know, that's why I'm not asking you. You don't get any of this? Okay. In standard form, it's ax squared plus bx plus c. And we're using everything that we're doing here involves those working with those three numbers. Okay. So can you tell me what a is now from that? -1, yep. And b is? And c is 3. Okay. All right, so then to find all these other things, we're just working with those three numbers and using all of these properties for a parabola. Okay. So that's why it's important that you are able to use these properties. So the first one says, all right, it opens upward if a is greater than 0 and downward if a is less than 0. So I always think of it this way, that if a is positive, it smiles. If it's negative, it frowns. Okay. So which way is it open, Caleb? Yeah. Okay. So a, it opens downward. And B, they want us to find the axis of symmetry. So that's the line that cuts the graph in half. And we find that by doing -b over 2a. All we have to do is plug in those numbers. Put -2 in for B and -1 in for A. So here we have the opposite of -2 over -2. So how many negatives do I have there? Which means it's going to be negative then. So this is -1. So the axis of symmetry, x equals -1. Right, so that means I could actually graph a dotted vertical line here at -1 right now, if I wanted to. Because I know that's where the vertex goes through that line. Okay. All right, letter C, they want us to find the vertex. All right, to find the vertex, I know this tells me the x value of the vertex. The axis of symmetry does. So to find the y value for the vertex, what do I have to do? Plug it in. Okay. So we put in, so we're looking for k because the vertex is hk. So I put in -1 for x. Now, one of the things that causes problems is that lots of times you guys don't square things correctly. Okay. Do I distribute this negative in front first, or do I square it first? All right, okay. We square it first. So what's -1 squared? Okay, that's 1, and then we have the opposite of that, so we have -1. -2 times 1 is 2, and then +3. So in this case, k is equal to +4. So my vertex is the point. H is -1, or x is -1. And y, which would be the k value, would be +4. So that's an actual point on my graph. Okay. Letter D, the y-intercept, is the value, just the value of C. So +3. Man, it must have been a long weekend. We got all these people with their heads down, tired, needing a nap. All right. So to graph this, We'll graph the vertex first of all, negative 1, 4. The y-intercept is at positive 3. So all I need is one more point then to graph it, and it'll be on the other side of the vertex then, the other side of the axis of symmetry. So it's going to be at the point negative 2, 3. Because the axis of symmetry is right here. And so my points have to be equal distance on each side of that axis of symmetry. So since the y-intercept is 1 over from the axis of symmetry, I'll go 1 over the other way. It isn't always 1. It was in these two examples, but it's not always that way. Okay. Then I draw my line, my graph. Yep. You don't have to. Okay. If you want to help you with graphing it, then that's fine, but you don't have to. Okay. You will not get marked down if it's there. You will not get marked down if it's not there. Okay. All right. I'm just identifying it to help with graphing. Okay. Minimum and maximum values. If it opens upward, it has a minimum. If it opens downward, it has a maximum. Now, the domain for all quadratic functions is all real numbers. The range, if it has a minimum, if it has a minimum, the range is going to be y is greater than or equal to k, the y value of the vertex. If it has a maximum, then the range is going to be y is less than or equal to k, the y value of the vertex. So we're going to be finding max and min values, and we're going to be finding domain and range. Always, okay? You heard that word, right? Always. The domain for a quadratic function is all real numbers. Okay? The range, if it's a minimum, y is greater than or equal to k. The range, if it has a maximum, y is less than or equal to k. Now, when we say what the minimum or maximum value is, it's just the y value. Okay? The min or the max is just the y value. It's not the point. The point is called the vertex. Okay? The min is the y value. The max would be the y value. Okay? All right, so we want to find the min and max for this quadratic function and then state the domain and range. Okay? So what do I need to find? Okay, I need to know whether it opens upward or downwards, but what else do I need to know? What thing up here is consistent with both of those? The vertexes, okay? The domain is, but also the vertex. The vertex is HK, right? Does this tell me what the vertex is? No, it doesn't. Can I find it? Yes, just like I did on those last problems, right? We find the value of x. So to find the vertex, we're looking for HK. H is found by doing negative b over 2a, right? Okay, that's the x value for the vertex. Axis of symmetry. They're the same thing. So what's the value of b in this problem? 2. Right? So we have negative 2 over, and what's the value of a? Negative 3. Okay? Which tells me what? Okay. But since a is negative 3, is that going to have a min or a max? Does it frown or smile? It frowns, so it's going to have a maximum. Okay? All right, so this is equal to the opposite of 2 over negative 6, which is 1/3, right? Okay. No, because that's 2 times negative 3.
Yeah. A negative from a negative is positive.
Right, that's where I got the,
Oh, okay.
I still have both negatives there.
Oh, okay.
Okay?
I thought.
Both negatives are still there, so it's
Okay,
going
I was
to, okay?
like.
All right. Okay. So the, what's that, Caleb? No, the negative, we have a negative here and a negative here.
So they just cancel out.
So they're going to cancel each other out. Yep, a negative divided by a negative is a positive. Okay. All right. Okay. So to find k then, I have to take the value of x and put it in to find that. Okay, so I've got negative 3 times 1/3 squared plus 2 times 1/3 minus 4. Okay. Now, I prefer not to use my calculator for this. You are not like me. So will your calculator give me this answer as a fraction? Because well, it'll give you a decimal, but then can you convert that to a fraction? Okay. All right. So here we get negative 3 times 1/9 plus 2/3 minus 4, which, let's see, that's negative 1/3 plus 2/3 minus 12/3. Right. So that equals negative 11/3, is that right? All right, check it out. Type it in your calculator and find the answer. Check, make sure I'm right. Okay, now hit math and fraction. All right, is that correct? Okay. All right, negative 11/3. So then, now I have to answer the question. All right. So it's a maximum, right? Okay. So the max is negative 11/3. The domain, it's a quadratic function, right? What do we say about quadratic functions? The domain is what? Okay, all real numbers. Okay. The range, if it has a maximum, okay, if it has a max, then the range is going to be y is less than or equal to k. So my answer then is, for the range, y is less than or equal to negative 11/3. It does take some time. All right, take out your calculator. Plug that in your y equals. This function. Put that function in your y equals. Okay? And then graph it. Y equals negative 3x squared plus. How come the graph has to be rounded? Because it is. It's not a V. Then it would be absolute value if it was a v.
Like if you put points in there, wouldn't it make it a straight line like you just did every point?
No, because if you put enough points, it would curve then. Yep. All right, so if I zoom 6 for my graph, then you should get this graph right here, right?
I did.
Did you forget to put an x somewhere or an x squared somewhere? Okay. All right. All right. Now, will my calculator find the max or min for me? Where's that at? Where at, John? Calc. So how do I get to calc? Second trace, right? All right? So if I go to second trace, oh, look at that. There's a minimum and there's a maximum there. All right, so we're looking for the maximum in this case. So if I press number 4, all right, okay. And then it says it asks for a left boundary. So this is what I'm doing. That means that I want to make sure I'm to the left of where that maximum is at, and then I hit enter. And so right now is 0, -4. Is that left of the max? If I can't tell, I can always hit my arrow key so it goes to the left, so I can definitely see that it is. Is this left of the max? Yes, it is. Hit enter.
Wait, what did you put after second trace?
Second trace, and I just made sure that the cursor was to the left of the maximum. Okay, and then I hit enter. And now it says right boundary, so now I need to go to the right of the maximum, somewhere over there, and then I can hit enter again. And then it says guess, all right? Well, I don't care about the guess. The guess, if there's only one maximum in there, it'll give you the one it wants just by hitting enter then. Okay, then you got to hit enter. Okay, now it says right boundary, right? Now move it to the other side of the maximum value. Move your cursor with the arrow keys. Okay, all right, then hit enter once you're over there. And now what it does then, let me go through it again. Okay, so when I go do this, all right, so I get to the left of it. Notice when I hit enter, what did it put on the screen? Okay, it put this arrow up here, okay, at the top of the screen to show me that's where that boundary point is at. Now I'm going to go to the other side, and you can actually just choose an x value. Like if I choose, I know that the x value 2 is to the right of it, right? So if I just type in 2 and enter, it'll also take me over there. Okay. Now there's the right arrow. Okay. So this shows me the boundary here, and now when I hit enter, then it takes me to that maximum value, which is at, what is this number here? 0.33333 is 1/3, which was our x value we found, right? And -3 2/3 is a -11/3. Okay, so we actually found it. So what did I just find here? Not only did I find the max value of -3 2/3, but I also found the, nope, not the minimum. This doesn't have a minimum. What do we call that point? The vertex. So I also found the vertex for it. Okay. So not only did that find the max or the min if I wanted to, that also told me what the vertex is. Okay.